This is Algebra Lesson 11.4, Histograms and stem and leaf plots. A graph that is often useful for small data sets is a stem plot, sometimes called a stem and leaf plot. A stem plot, like a dot plot, displays each individual data item, but data values are also grouped into intervals or bins. At right are the handspans of 26 algebra students. Create a stem plot of the class data. So to make a stem plot, we want to find our minimum and our maximum values. That's going to help us scale our graph. I see 18.5 here. I don't see anything higher than 18.5. Or, sorry, lower. I don't see anything lower than 18.5. Why? And then my highest data value, I see 21. I see 23. Okay, so that means I'm going to scale from 18 to 23. So I'll start with 18, 19, 20, 21, 22, 23. And then we're going to draw a vertical line. This is the stem of our number, hence stem plot. And then that line is going to separate the leaves of our stem plot. So we're going to have 18, and look for all of our data values that are 18 something. So I see 18.5, 18.7, and I see no other 18s. So I'm going to write a 5, and then I'm going to write a 7, reading 18.5, 18.7 as my numbers there. I'm going to do the same thing with all of my 19s. Now, ideally, you want these numbers to go lowest to highest. That's why I wrote the 5 first and then the 7. So all my 19s, I see 19.9. I think I'm going to write these here so that I can organize them a little easier. 19.9, 19.0, 19.5, 19.5, 19.3, 19.0, and that's all of my 19s. So I see two zeros, 0, 0. I see a 3, I see two 5s, and a 9. So I wanted to write them out so that I could organize them lowest to highest. And we'll look for my 20s and do the same thing. I see 20.0, 20.5, another 5, another 5, 6, 2, and 8. So that would be 0, 2, 5, 5, 5, 6, and 8. 21s, 0, 0, 3, 5, 2, 2, 3, and 5. Two zeros, two 2s, two 3s, and two 5s. I'm trying to line these numbers up so that we're kind of being able to see the same number in each column. So that we can kind of easily identify. I don't want to squish them together and then one column or one row will look longer than the other one. And 22s. Got a 5. Move those over here. And a 1. And that's it. So 1 and 5. And then 23, I see 23.2 right here, and I don't think I see any other 23, so that'll be just a 2 here. I'm going to count to make sure I got them all, but this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 1, 2, 3, 4, 5, 6, 7, 7. Well, let's do 4. 1, 2, 3, 4. 24, 25, 26. Looks good. So this is my completed stem plot. So we can see most of my values are in the 21s, right? 21.0 all the way up to 21.5, because that was my longest list of numbers. if you kind of think about this, it's a histogram, which we're going to talk about next, or a bar graph kind of turned on its side. So we would have 2 in the 18s, and then 1, 2, 3, 4, 5, 6, a 6 tall bar in the 19s, and a 7 tall bar in the 20s, and so on and so on. So it's like a histogram because it's showing you how many data values are in each chunk, or interval, or bin. All those words mean the same thing. But it's also more detailed than a histogram because it does show you actually each individual data point, not just a summary of those data points. So next we're going to talk about a histogram. And so we're going to use these test scores to make a histogram. Again, we're going to group or chunk the data, but we're not going to be worried about each individual data point, how many in each interval or bin or chunk, same word. But we're going to find our minimum value. Our minimum value in this case, I see a 45, I see a 38. I think 38 is our minimum value. And then our maximum value is 91, 94, 98, 98. So I like to pick up my minimum max first because they're going to help me scale my axis. So I need my axis to go from at least 30 to at least 100. Let me count this here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It's perfectly set up so that I can just go by tens. 20, 30, 40, 50. So I'm not going to label them all, but I can see then going by tens across the bottom. Each of my bars is basically going to be how many in that group of 10. So how many from 0 to 9 here? I have none. How many from 10 to 29? Sorry, 10 to 19 would go here. And I'm going one short because it's the number would go into the next bar. So this bar specifically is 0 to 9 because this bar here would be 10 through 19. And then this bar here would be 20 through 29. So I don't want to say 20 to 30 because then if I had any 30 values, I don't want to put them in both bars. But all of these are going to be empty because I know my lowest value is 38. And I only see one value in my 30s. So this is my zeros, my 10s, my 20s, my 30s would go here. I have one value in my 30s, so I'm going to draw a 1 bar there. Now in my 40s, I see one value, I see one value. So another 1 value in my 40s. And again, I'm not worried about if that value is 45 or 47 or 42 like I did on the stem plot, just how many values I have. So next is my 50s. I see 0 values in my 50s. 60s, 1, 2, 3. So in my 60s, this is my 60 bar, 1, 2, 3, means I'm going to draw my bar here. In my 70s, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So my bar would be here for my 70s. In my 90s, in my 80s. 80s, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then finally my 90s. 1, 2, 3, 4, 5. 5 values in my 90s. 1, 2, 3, 4, 5. So it's not detailed like the stem plot, but we're really just looking for a distribution. We don't need all that detail when we have large data sets. So I have most of my values in the 70s here. Also lots of values in the 80s and 90s. A few in the 60s, and very few, only 2 data values below 50. Some people like to shade these to make them look nice and pretty, especially if you're using black ink on a black graph. It can be kind of hard to see your bars. That's why I tried to outline them pretty bold. But that is my completed histogram. And that is it for the notes on this one. Good luck on the exercises, and let me know if you have any questions.